Okay, welcome back to Calculus 2. So we are looking at problem 1D. This is the limit as n approaches infinity, negative 1 to the n times n divided by n plus 1. So you've got this right here. So you might first think like, hey, I could try the alternating series test, and that's not a bad thought, except that this is not a series. This is a sequence. The alternating series test is not going to help. So what we're going to do is we're going to take our limit. Here we have a limit as n goes off to infinity. So we're going to say let n equals 2k to deal with the even ones. And then in the next problem, in the next part of the problem, we're going to say let n equals 2k plus 1. Okay. And we're just going to divide the problem into two different pieces here. So we're going to have negative 1 raised to the 2k power times 2k for my n divided by 2k plus 1 on the bottom here. Okay. What this is going to do is it's going to make everything here as an even value. So this negative 1 is always going to be negative 1 raised to an even power. It's just going to be 1. So we have 2k over 2k plus 1. We can go ahead and divide top and bottom by 1 over k, right? We're taking our limit as k goes off to infinity here. So we're going to have 2 over 2 plus 1 over k as k goes off to infinity. This is going to give us 2 over 2, which is equal to 1. Okay, so when n is equal to 2k, our limit is equal to 1. Okay, now, what if we set n equal to 2k plus 1? Okay, so this is part A, part B. N is equal to 2k plus 1. So what we're going to do here is we're going to say we have negative 1 raised to the 2k plus 1 power. That's always going to be an odd power. So this is always going to be a negative value here. Here we have 2k plus 1 times all of that. And on the bottom, we have 2k plus 1, right? And plus 1 here. So we have 2k plus 1, okay? And then we have 2k plus 2. And again, I'm going to multiply top and bottom by negative by 1 over k's. So we're going to end up with 2 over 2 plus 1 over k plus 2 over k. Okay, 2 over k. These pieces are going to go to 0. So we end up with 1. But it's times this negative 1 raised to 2n plus 1. So this is always going to be times negative 1 here. So this limit goes to negative 1. So we have a situation here where if the n is going to be even, then our limit is going to be 1. But if our n is going to be odd, then our limit is going to be negative 1. So we've got a sequence that's kind of bouncing up and down between 1 and negative 1. Okay. So one of the things that people have a hard time remembering is that mathematicians, we don't have a lot of good words for things. So we just say, oh, did it converge? Like, no, it didn't settle on a value. Then it diverges. Does that mean it shoots off to infinity? No, it's not shooting off to infinity. It's just ping-ponging between negative 1 and positive 1. So that diverges because it never settles on a value. And that's the thing you have to remember about like what convergent means is it settles on a value. So this thing is constantly ping-ponging back and forth. This sequence diverges. It doesn't go off to infinity, but it does diverge, okay, because the limits don't agree. So that's how you do a problem like that. I really wanted to show you this one because this one's a little bit tricky, but you know, keep studying, keep practicing, and try to practice all the problems before you go out and take your exams. Okay. Thank you very much for watching the video. I'll see you in the next one, and take care.